Okay, now I'm going to solve exercise 18 on page 119. In here they tell me that a car is moving at 54 kilometers per hour. Then they tell me that this car accelerates with an acceleration of 2 meters per second square during a time of 5 seconds. And they ask me to draw the velocity time graph. So we know that because there is acceleration, we're going to identify the variables that we have. So this would be acceleration. This would be time taken, this would be velocity, and we know velocity is changing because there is acceleration, so we have a uniformly accelerated linear motion, and they ask me to draw the graph, okay? This would be the initial velocity because it's the velocity at which the car is moving to start, okay? So we're gonna do the graph. So I'm going to start by drawing the axis. Please use graph paper with the small squares to help you. We're gonna write here time in seconds, and we're gonna write here velocity in meters per second. So remember that we're going to use SI units, okay? SI units. Okay, so the first thing is we notice velocity is not in international system of units. So we're gonna do the change of units in here, okay? So we're gonna go initial velocity 54 kilometers per hour. I'm gonna transform the kilometers into meters. I'm going to transform the hours in seconds. I do the calculations and I obtain that initial velocity is 15 meters per second. Most of you did the change of unit correctly, okay? So what I'm going to do is I'm going to change this initial piece of information and I'm going to write it in the international system of units. So we have 15 meters per second, okay? I'm going to erase this. And now we're going to do the graph. So in order to do the graph, we have to see, okay, how long does it take for this motion to happen? So it takes 5 seconds. So what I'm going to do in here is write the 5 seconds in the time axis, which is always the horizontal one, okay? So we have 1, 2, 3, 4, and 5 seconds. Remember, they have to be equally spaced. So the distance between 0 and 1 has to be the same as the distance between 1 and 2, 3 and 4, and so on, okay? So the most important mistake that a lot of you did was putting number 15 in here, number 0, and drawing a line like this. This is not correct because 15 meters per second is what we call the initial velocity. So let's see what the final velocity is, okay? We have the velocity equation, which is v equal v0 plus a times time, okay? And we can replace it. So v equals initial velocity, which is 15, plus acceleration, which is 2, multiplied by 5. So this is 15 plus 10, which is 25 meters per second. This means that after 5 seconds, the car has reached a final velocity of 25 meters per second. So in here, I should go, for example, like 5, 10, 15, 20, and 25, because I have to make sure that I reach 25 meters per second, okay? Okay, remember for this to be equally spaced. I'm gonna write in here the data. So we have our final velocity equal 25 meters per second, and then we're going to represent this, okay? So the initial velocity is 15 meters per second, and the final velocity is equal to 25 meters per second. So we join this together, and this is the velocity time graph. So initial velocity when time equals 0 is 15. Final velocity when time is 5 equals 25. If you want, instead of doing just 2 points and joining them, we could have made a table with all the values, like something like this. Time, velocity, time, seconds, velocity, meters per second, and then thinking, okay, 0, 1, 2, 3, 4, and 5. and saying, okay, when time is 0, velocity is 15. When time is 1, so when time is 1, we have to add this, okay? So it would be 17 because we added 2 meters per second squared. So from 15 we go to 17, okay? When time is 2, it would be 19. When time is 3, 21. When time is 4, 23. And when time is 5, 25, okay? So because acceleration is 2 meters per second squared, that means each second it accelerates 2 meters per second more. So we go until we reach 25. You can take it in here. For time 1, it should be 17, yeah, something between 15 and 20. For time 2, 19, closer to 20. For time 3, 21, it's already over 20. For time 4, 23. And for time 4, 20, for time 5, 25. Okay, hope you understood the video.